Welcome to the final phase of the numericals of my dear Bohr's postulates. And the best part is we have got an advantage. That drawback of this Bohr. Trust me, you will enjoy this. Now, before I begin with the drawback, let me start with an electron in hydrogen stays in second orbit for so and so second. So what? Big deal. How many revolutions will it make till it jumps to the ground state? Now that is an interesting question. Quite to think about. Think. It stays in second orbit. Then it comes down to the ground state and number of revolutions per second. Quite is challenging sum. So what is given basically? I will tell you. Is that the time is given, fine, big deal. And to find the number of revolution. And when I say number of revolution, the formula is frequency. And frequency you'll get from the formula of energy. And then energy delta is equal to h into nu. When you use what? Frequency. The solution is from the formula nu is equal to delta E by h. And when I say delta E is the difference of energy. From which energy to which energy? Second to first. So E2 minus E1 upon h. So E2 I know it is 3.4. E1 is equal to 13.6. With the minus sign, don't forget, minus get cancelled. So what you get is nu is equal to 10.2 into 11.6 into 10 raised to minus 19 upon 6.6 into 10 raised to minus 34. Did you get it? Yes or no? And once that is done, what you can see is 10.2 into 1.6 into 10 raised to 15 upon 6.6. And I just reduced it, the 10th power. And now what I will do is, I will take one boring step of log and anti-log. So anti-log of this, okay, multiply gets plus, dividing sign gets subtracted, and what you get is this. Keep 10 to the power out. Don't include the bracket, please. I must not tell you again and again. And after finding the log means characteristic and mantissa. Characteristic means number of digit before decimal minus 1. And mantissa is group the digits and find it in the log table. After subtracting it, I will get so and so number. So in 0.39, go to 1 and then to 2. What you get is this number, don't you? And this is your frequency. Ladies and gentlemen, these many revolutions in 1 second. But that's the spirit. Sum has not yet ended here. There is still one more thing. They are not asking about 1 second. They are asking 10 raised to minus 8 second. So what you do is you have to simply multiply it with 10 raised to minus 8, my dear students. You will get the frequency then. Awesome sum, beautifully done. And now let's come towards the drawback of Bohr. Look at the Bohr. Your theory is crazy, buddy. It is crazy. Lest not crazy enough to be true. So we forgive you, buddy, but still we would like to see your drawback. First, you never explained us any other spectrum apart from hydrogen. Dear students, don't you agree with me? See, in Bohr's first postulate, he told centripetal force, we told okay fine, mv square by r. He told is equal to electrostatic force, we told agreed, yes. But in that electrostatic force, if you remember, there was 1 upon 4 epsilon 0 e square. Now why wasn't it ze square? If I would have taken beryllium nucleus or lithium nucleus, I would have got some other number, maybe 3ze square, maybe 9ze square. So did you explain that, Bohr? No, you didn't. That was your drawback. Second, no proof of quantization. Oh, hello. Where is the formula L is equal to NH upon 2 pi? Where did you prove it? Those formulas which come without any proof are called empirical formula. If you remember, we did the same thing for Rutherford. And we did the same thing for Balmer. And now it's Bohr. So Bohr, even you have to check out. And not in accordance with dual nature. Now what is dual nature? What exactly is dual nature? This is dual nature. What I would like to show you is somewhat like this. A bulb emitting a light. The light is first coming in from terms of wave. And second, it's also coming in terms of particles. You can see those lines, the vertical lines coming 1, 2, 3, then 1, 2, 3, then 1, 2, 3, then 1, 2, 3. Every energy, every matter has dual nature. Did you explain? Did you take in consideration? Did you consider the wave nature? No, you didn't, Bohr. And that's where Einstein says, Bohr assume electron as a particle does not consider as a dual nature. No, you didn't. Neil Bohr. But any which ways, I would like to appreciate the efforts taken by Bohr, for which he was awarded the Nobel Prize. And that is what the beauty is. Through his postulate, we got an exact mathematical tool to analyze what an atom is. Dear students, I am very much sure you must be eager for your next module, because in next module or after some modules, we'll be having more and more idea of what duality is. When I speak about duality, my dear students, if you are you, you can be something else. Means, if you are a matter, you can be a wave. And that's the beauty of dual nature. I like to conclude my module with the drawbacks of bohr. See you all very soon in my next module.
ये मिला लाइट बिल भरा कहाँ था रसमलाई